All right, in this video, we're going to introduce conditional probability, learning target 6. In the previous probabilities, we've been counting our sample space and using the entire sample space for every probability, but when you put a condition on the sample space, it limits the sample space. So we'll talk a little bit more about that as we get further along, but the conditional probability is read this way. The probability, the P, parentheses, B given A. The P stands for probability. The B is event B, and the vertical bar is how you is when you say the word given. So whatever's after the vertical bar, the A is the given condition. So A is the given condition. You find that using the formula probability A and B divided by the probability of A. The formula we will use to explain a couple of problems, but eventually we'll go back to learning target 3's definition, where if you can just count the total number of items and count the number of successes, you can create your probability that way. So the first part of the notes is all about this one graph. We're going to interpret probabilities based on this table. Sorry, not graph, table. So I'm going to give you a few numbers without having to actually add them up, because we'll need these as we go along. But if you looked at the first column here, the under 25,000, there are 125, 100, 21, 2. There's a total of 248 people that earned under $25,000 at this company. There's a total of 352 that earned 25 to 35,000. There's a total of 400 that make over 35,000. If you add all those up, like the problem says at the beginning, you have 1,000 people working for this company. We're also going to need to know the various amounts of people that have achieved a certain amount of education, so we'll need these rows added up. The 125 plus the 82 plus the 2 gives you 209. A high school diploma gives you 245 if you add all those up. 279 here, and 267 here. So, all right, for the first problem, number 1, we're not going to go into the new stuff. We're doing an old problem, a learning target 3. Find the probability that if you pick one person at random, that person has less than a high school education. So of the 1,000 people, how many have less than a high school education? Well, that would be the 125, the 82, and the 2. So that's that 209, which is 20.9%. For this target, we're going to stay with fractions that aren't reduced for the sake of being able to check our answers. And when I'm looking at your homework, I can kind of tell where the numbers came from, because when you reduce the fraction, sometimes the numbers that you get, you're not really sure where they came from. So, all right, let me erase that. All right, number 2. Now we are looking at the given conditional probability. So number 2 is read this way. Find the probability of picking a person that earns under 25,000 given that the person has less than a high school education. All right, for this question, we're going to use the definition, the formula above. So we're going to find the probability of A and B. So for this question, that would be a person that earns, let's see, this would be the A, this would be the B. So we're going to find the probability of getting a person that has less than a high school education and earns under 25,000. So less than high school and earns under 25K, divided by the probability of A, according to the formula, and in our question here, it's less than high school education, so divided by the probability of less than high school education. That's a strict use of the formula. So let's find the two probabilities. First, the probability of getting a person less than high school and under 25. Let's see, less than high school and under 25. That would be the 125 people in that box. So 125 out of 1,000. 125 out of 1,000. All right, that's the top of the fraction. So that's 125 out of 1,000. Probability in the denominator of getting a person that's less than high school. Let's see. That's 125 there, 82 there, 2 there. That's the 209. 209 people out of 1,000. 209 out of 1,000. All right, so back down here, 209 out of 1,000. All right, if you are dividing fractions, the rule says flip the second fraction and multiply. So 125 over 1,000 times 1,000 over 209. Your thousands reduce, and you get 125 over 209, which is, pull up the calculator here. Delete that. 125 divided by 209 gives you about 59.81%. So 59.8%, we'll go with that. 59.8%. And in the future, I'll just give those numbers and not use the calculator because the focus of the lesson is coming up with the fractions in the first place, not teaching the fractions turning into decimals or turning into percents. So let's now erase all that work for number 2. I'll erase this and put those two back. Let's see, 209 and 245. And now we're going to redo number 2 using Learning Target 3's definition. And we'll kind of see something happen that, well, I think we'll like. Number 2, we're doing it over. Find the probability of earning under 25,000 given that the person had less than a high school education. If it's a given that the person you're choosing had less than a high school education, and you're choosing a person that is in that, or that row, they're in that row. The only people that have less than a high school education are the 125 here, the 82 here, and the 2 here, the 209 people in this company. So 209 people to choose from. So if that's given, what's the probability of picking someone who earns under 25,000 in that given set of numbers? That's the 125. Now, if we compare what we just got, 125 and 209, to our reduced fraction, or to our fraction over here, that's how you can skip straight to finding the probability that way just by counting your successes and counting your total possible, knowing that the given statement reduces your population down to 209 people. All right, that may be a little confusing, so let's try number 3, and let's do it with the formula first, and then without. With the formula, all right, you may need to pause the video or scroll back to I'll scroll up to the top one more time for you to see the formula, P of A and B times P of A. Using the formula, this is B, this is A. So we're going to find the probability of earning less than 25,000, A, and B, which is college degree, and divide that by the probability of A, which is less than 25,000. Okay, those probabilities are, all right, probability of getting someone less than 25,000 and college. Less than 25,000 and college. That would be those two right there. So 2 people out of 1,000 divided by the probability of getting a person that's that earns less than 25,000. A person that earns less than 25,000 is anyone in this column. So that one, that one, that one, and that one, which is our 248. So 248 out of 1,000. If you divide those two fractions, you flip and multiply the bottom fraction, and the thousands will cancel. You get 2 out of 248. which is exactly what you would get 2 out of 248 if you did the question this way. Think about it as given that the person earns less than 25,000. If it's a given that the person you're choosing earns under 25,000, it's a given your person is coming from one of those 4 places. So there's only 248 people to pick from. Of those 248, how many ways can you pick a college degree person? 21. I'm sorry, that's the wrong one. Hope that wasn't too confusing. 2. There are only 2 that have a college degree. So 2 out of 248, same as 2 out of 248 if you use the formula. So from this point on, we're not going to use the formula. We're just going to use the given information to reduce our sample space. By the way, that probability turns into a percent of approximately 0.81%. All right. I know that's been probably a little bit confusing up to this point. So now let's try to do number 4 and number 5 using the easier of the 2 ways to solve the probability. All right, so the easier of the 2 ways, again, is to take the given information. So at number 4, it's a given that the person earns 25 to 35,000. Take that and reduce the 1,000 employees down to however many fit that description. So if we look back at the table, from 25,000 to 35,000, there's a total of 352 people. So there are 352 people that fit that description. Of those people and only those people, which means you're no longer looking at any of those numbers. Of those people, how many of them only have a high school diploma? That would be 134. So 134 out of 352. 134 out of 352, which reduces to the percentage, or is the percentage about 38.1%. All right, 2 more. Number 5. Find the probability of picking a person who earns 25,000 or more, given that you're picking a person that only has some college education. So you start with the given, only some college education. Let's erase our previous work. Only has some college education. Only has some college education. That is these folks, which is 279 of them. So 279 people fit the given, fit the condition that's given here, the condition on this conditional probability. Of those 279, how many earn 25,000 or more? All right, this is tricky. 25,000 or more. These people earn 25,000 or more, and so do these people. So 115 plus 143. 115 plus 143. There are 258 of these people. So your probability success is 258 out of total. Once you restrict the 1,000 employees down to the given, there's only 279 to pick from. So that percentage is 92.5%. The last one. What's the probability of choosing a person who has at minimum some college if it's a given that they earn over 35,000? Let's see. Over 35,000 earns over 35,000. The people that earn over 35,000 are right there. There's 400 of them. So out of 400, how many people have, of those 400, how many have at minimum some college? At minimum some college. These people, 143 of them, have some college, and so do these people. They have some college because they graduated from college. So 143 plus 244. 143 plus 244 gives you 387 out of 400, or approximately 96.8%. So to recap this part of the target, when you're dealing with conditional probability, they give you a condition that takes your sample space from the original, whatever it is, like in this problem, the original had 1,000 employees. As soon as you say given blank, whatever that blank is, it takes those 1,000 employees and just says pretend that, or says to basically ignore those that don't fit the given. So if I said find the probability of picking someone given that they earned over 35,000, you're only looking at the people who earned over 35,000. You're not looking at 1,000 employees, you're only looking at 400. So that's a conditional probability.